In this video, I am going to talk about some important methods we use to solve systems of coplanar forces. In advanced level mathematics paper, first we have to draw correct force diagram to solve this problem. Forces are vectors, so we have to show the directions of these forces using arrow heads correctly. If we draw wrong picture, our answer will be wrong too. So first we have to draw or sketch force diagram correctly. Then we have to talk about some important states of the system. First I am going to talk about the equilibrium state of a coplanar system. So to be in a equilibrium state, the system must satisfy these three conditions. First, uh, first I'm going to for equilibrium. Equilibrium. First condition is addition of horizontal forces must equal to C. Addition of horizontal forces must equal to 0. We denote this as, normally we denote horizontal forces as x and direction as this. So for equilibrium, the x components or x horizontal forces must be 0. The second one is addition of vertical forces must equal to 0. We denote this as y components equal to 0. The last condition is moment around any point must be 0. So normally we denote taking moment as using G letter, and the point where we take moments as example point A, and the direction clockwise or anti-clockwise must be equal to 0. So for the system to be in a equilibrium state, system must satisfy these three conditions. Then we talk about to system to be equal to kappa. To be equal to kappa, system must satisfy these three conditions. I am not going to write this as before. I am using using the symbols I use in first explanation. So first, horizontal forces must be equals 0. Additions of horizontal forces. Second one is addition of vertical forces must be equal to 0. Third one is moments around any point must not equal to 0, and moments around any point must be equal. So if we take moment around 2 points, answers must be equal. So that is the value of the couple. The moments value of any point give the value of the couple that equal to the force system. And last state, where the system have a resultant force. To have a resultant force. For this state, the vertical forces must not equal to 0, or y components or vertical forces must not be equal to 0. In this condition, can explain like this also. So this condition must so one of these can 0 but not the both. So I can take as x component 0 but y components not equal 0. So then we have a resultant force, or x component not equal 0 and y component equal 0. Then also we have a resultant force. Otherwise, x component not equal 0 and y component not equal 0. Then also we have a resultant force. Next I am going to talk about how to move resultant force to any point we want. So I am taking a simple example. I draw a parallelogram and extend one side. Right? This system has a resultant force which act like this. Right? This is the resultant force. I want to move this force acting through the point A by adding a couple to this force system. There is a forces, right? I didn't write them. Just an example, right? Imagine there are some forces. So I have to add a couple to this system and move this resultant force acting through the point A. To do this, I am going to do first. I'm gonna add force opposite direction of our resultant force, and it has same value. Right? First I am going to cancel out this resultant force, and I am going to add it through our point. So I want to add this force which act through point A. So as you can see now, this our first initial resultant is now cancelled, and new resultant force is acting through the point A. And the system, there is a, we add a couple to the system. This is the couple. I circled it. By adding a couple, we move our resultant force to given location, and we can find the value of the couple by finding the perpendicular distance between two forces. We have a value of r. If we find the perpendicular distance, we can find the couple value of the couple. And think then we have to find the resultant force, that we have a x components value equal to x and y component value equals to y. Then we can write resultant as x squared plus y squared square root. So we have a x value and a y value. Then our resultant force acting between them, and it equals to r. Then r give the value x squared plus y squared square root. And I can find the direction or angle, right? I take this as alpha, then I can write an answer for the tan alpha. Tan alpha equals to y divided by x. Then alpha equals to tan inverse y divided by x. So here I find the angle make with the horizontal, but you can find also the angle make with the vertical also. It is depend on the question. We can use these methods to solve coplanar system of forces very easily. This is not a hard question, but we have to remember these theories to solve it quickly and accurately. So in next video I am going to solve past paper problem using these theories. See you in next video.